Okay, so lesson 2-7, it's the last lesson of chapter 2, and we are using function notation. And so instead of having y equals, we have the function of x equals, which just means y. So I don't want that to confuse you. So what am I talking about? So anytime you see f of x, that goes for g of x, h of x, I don't know, z of x, whatever you see, all that means is that it is y. It is that dependent variable. So if you see something like f of 3, what does that mean? That means what is the function y when x equals 3. And we're talking about this up here, the f of x. So let's look at this up here. Y equals 2x plus 3 is the same as f of x equals 2x plus 3. F of x is read as f of x, okay? And the letter f is the name of the function, not the variable. F is not a variable. Okay, f is just the name of the equation. Other letters can also be used, such as h and g, okay? And the more that we work with this, the more that you're gonna understand, okay? All right, so let's look at our first example. It says that the function w of x equals 250x represents the number of words, w of x, you can read in x minutes. How many words can you read in 8 minutes? So let's complete the equation. We have w of x equals 250x. Okay, so then it asks how many minutes or how many words can you read in 8 minutes? 8 is our independent variable. That is what the x is. So we would write this as w of 8 equals 250 times 8. And then we can solve it. Okay, what is 250 times 8? 2,000. So let me show you what it looks like when we did it without the function, okay? What it really is just y equals 250x. And this is what you're used to, okay? You're used to writing it as y equals. You only have to write it as a function if that is part of the problem, okay? You don't have to write it as a function f of x or w of x or h of x if it is not part of the problem.
So,
Okay.
Ms. Weatherman, whenever you're graphing, do you use f of x?
It just depends on how it's written in the problem. Usually, so if it's a graph without that function part in the problem, then you just use y. So our answer here is 2,000 words. This would be our final answer. This is how you would need to write it out with the units attached, okay? So example 2 is very similar to this. So I want you to try this one on your own and then we'll come back and check it. Oh my gosh. Oh no, okay, good. I thought I didn't record. Go ahead and check your work and see if you were able to do example 2. You're not going to be doing both examples on your homework. You're going to be doing the function rule, okay? Questions? Did you have a question, Ellen? Okay. All right, so let's come down to the bottom. We need to be very careful with this next one, and I'll explain why in just a minute. So if you are given an equation, f of x equals negative 1.5x plus 4, and it tells you that the domain this right here is over here. And they want to know the range. Where does the domain go in the equation and what does the range represent? Do you have any idea based on the previous two lessons we've learned? Lauren?
The range is your y,
Mhm.
and your domain is your x would be after the variable x plus y.
Mhm. Exactly. So your domain is what all of your x values are going to be here. And when you solve your equation, you're getting your y, which is your range, okay, or your f of x. So let's do the first one here. I know that my domain is going to be 1, 2, 3, and 4. So I am going to be solving 4 equations. Okay, so the first one is, and then my function is f of x equals 1.5x plus 4. So every single one of my domains will go into my x.
Negative. So do you have to?
Oh, negative 1.5. Thank you. Huh?
So do you do it like one by one?
Yes. So this is what I'm going to do. My function of 1 equals negative 1.5 times 1 plus 4. The next one is going to be the function of 2 equals negative 1.5 times 2 plus 4. The function of 3 equals negative 1.5 times 3 plus 4. And then the function of 4 okay. And so I will be solving each one of these separately to determine the range that matches my domain values. Okay, so we can go ahead and solve all of these. And I'm going to give you a minute to finish solving the rest, okay? Okay. So when you are finished, go ahead and check your answers. Now, are there any questions as to the answers? Okay. I am going to show you then how to write your final answer. So we have the domain here. Our range is going to be written as, we're going to write it in order from least to greatest. So -2, -0.5 or -half, 1, and 2.5. Okay. So on your homework, you will write your final answer like this. And just so you know, I would write this by example 3. This is for 11 and 12 in your homework. Okay. Okay. We're going to move on to a similar problem, but this time, instead of being given the domain, you're given the range. And a lot of students get this confused. They go straight to assuming that these are all going to be your x's. Okay, you can't do that. So let's look at this. The range of f of x equals 3x, this is your range, is 0, 3, 6, and 9. What is the domain? You are finding the x. Okay, so we want to know what the range is. No, we want to know what the domain is. We're given the range of 0, 3, 6, and 9. And our function is f of x equals 3x. So we're trying to figure out what that x is. So how are we going to write our first one? If we know that our first range is 0, where are we going to put that in our equation, Yana?
Maybe instead of the f of x, that just means y.
Mhm.
So we put 0 equals 3.
Exactly. So we're going to put 0 equals 3x. And then we'll solve for 3 equals 3x. Then we'll solve for 6 equals 3x. And then 9. Okay. That's all you're doing. So then when you solve this, you divide both sides by 3. What's 0 divided by 3?
0.
0. So 0 equals x. And then you would write your final answer domain. Put them in order from least to greatest. They're already that way. Okay. And to help you, this example covers 3 and 4 in your homework. So just if you need help with those, the biggest thing that you need to remember is what are you given and what are you finding? Okay. Make sure that you're not finding the range on everything. All right. Let's go ahead and move to page 2. Oh, mine is. Okay, on page 2, let's see what we're doing. We're identifying reasonable domain and range. So we did this a little bit with intervals in one of our last lessons. So let's see what we have here. It says you have 3 quarts of paint to paint the trim of your house. A quart of paint covers 100 feet squared. The function A of Q is 100 times Q, represents the area A of Q in square feet that Q quarts of paint cover. It's a lot of letters, right? What domain and range are reasonable for the function? What is the graph of the function? Okay, so let's start with the equation. It says that the function, let's just say y equals 100x. Okay, represents the area y in square feet of the X quarts of paint. So your area equals 100 times X. What does the X represent? The quarts. So it looks like for every quart, you multiply it by 100 to get the total area it will cover. Okay, so I am going to write my equation right here. A of Q equals 100, 100Q. Another way to write this is y equals 100x, just to make it a little bit simpler. Okay, so what is our independent variable here? X or Q, right? And so I'm going to put quarts. And then our dependent variable is the area. So the area is going to depend on how many quarts of paint you have. Okay, so now let's look at what the reasonable domains can be. All right, you have 3 quarts of paint. The max can be 3. So here's our max. And so we'll start with 0 and do 1, 2, and 3. So the maximum is 3.
busing.
So the maximum area we are going to be able to paint is 3 times 100 or 300. Right? And so then you can fill out the rest of this chart based on the equation. Okay. So what I want you to do right now, because I know you already know how to graph, we've been graphing for a little bit. I want you to set up your graph and then you're going to check yours with mine to see if you're remembering all of the details that you need to put in the graph. And then your increments, you could choose your increments, but I don't want you to go by 100s. Okay, so choose the increments that you're going to use carefully. All right, and then we'll come back and check. Okay, check your table and your graph, or check your graph. We've already checked our table. And make sure that it is similar. Now, if your increments are a little bit different, so I went by halves here, but I skipped a line, then 1, 2, 3, 4. And then I went by 25s here. And so it's 25, 50, 25, or 75, 100, 125, 50, 170. So I went by 25s. And so if you didn't skip a line, it might look a little bit different if you went by 50s. Yes.
For like the bottoms, I grew by 0.25.
Oh, yeah, that's fine. Yeah, so it'll be, your line might be a little bit flatter. Okay, any questions on the graph? Okay, so if you remember about intervals, we talked about reasonable intervals. Well, reasonable domain and range are the same. Domain intervals are going to be talking about all of our x's, and range is representing our y's. So what is the reasonable domain for our situation here?
0, 1, 2, 3.
Huh? 0,
1, 2, 3.
0, 1, 2, 3. Yes. Now, can our quarts be any increment between 0 and 1? Can I use 0.25 quarts?
Yes.
Can I use 0.76234 and on quarts? Yes.
You only have 3. You said 7.
But the max.
0.7.
Oh.
Yes, I can. Okay. So then we're going to start off with our Q like this, and it can go anywhere from 0 to 3 quarts. So what about our range? It could go anywhere between 0 to 300 because we only have 3 quarts. So that's the maximum it will cover. 0. And then this one is A of Q to 300. Okay. All right, any questions about this? Okay, so I'm going to give you a little bit of a challenge that I know you're going to be able to do easily. Is I want you to read the situation and you can work with your partner. You are going to come up with your own equation. And I want you to try to come up with your reasonable domains. Okay? Reasonable. Think about the situation. Okay? So I'm going to give you a few minutes to work on that before we come back. Okay, so yes, I know some of you went on because you were able to figure it out. So this should be your equation, one of these. This is using a function. This is just using y. So our hours, reasonable hours, had to start at 15 and go to 35 because it says that he works between those hours. Remember though, okay, well, I'll get to that in just a second. So then your salary, you would need to multiply 7 by each of these. How many of you have already done this?
Yeah.
Okay, so I'm just going to plug those in. 105, 140, 175, 210, and 245. Great. Okay, so those are the numbers you should have. Now we're going to look at the reasonable domain and range. And what we have to do is we have to say, okay, in our domain, can hours be in like minute increments? Can it be any increment between 15 and 16 and so on?
Yes.
Yes, it can. What about our salary?
Yeah.
It really can. They round it, but it can be any amount. So we're gonna write it in this type of interval notation, okay? And so our domain, anybody want to volunteer the domain? Sam,
15 is less than H.
yep, less than or equal to.
Less than or equal to, yeah, and then Friday, and then H is less than 35, less than or equal to 35.
Perfect.
The S right there. It's just
That's the
that's
domain.
It's just,
because
oh, wait.
It should be on the.
range is the S.
This is, oh. You're right. Sorry.
Why did you put it like, oh, what it knows number?
Okay, so now the range. Colby, what's the range?
105 is less than H, which is less than 245.
I was writing that wrong. Okay, so look at the bottom part. It says, what does each value in the ordered pair 2140 mean in the context of this problem? So using words, I want you to tell me, what do these two numbers mean? Okay. Grace?
The value of 20 represents the amount of hours, and the value of 140 represents the salary for 20 hours.
Great. And so if we were to put that into a sentence, we could say, when Joe works 20 hours, he will earn $140. So let's write that out. Yes, this isn't, this, I maybe need to change $7 to more like 10, right?
Yeah, it's because he's broke. He has no money. And
10. Oh, yes, 10 is too easy. So maybe like 12 or something.
Yeah, he's joking.
Okay, moving on to our last page. You are going to do this one on your own, very similar to what we just did. Okay, so work with a partner on this, and then we'll get to the fun stuff on the bottom. So I'm going to give you about 3 minutes. Okay, so this would be your equation. Either way you would write it would be fine. We,
Oh my gosh.
Oh.
That was so rude, Joe.
I'm just.
What is wrong?
I know.
He is brutally honest.
Mrs. Weatherman,
Sorry.
can you check that last one? Okay, so
I just saw it, I'm like, what's wrong?
it's okay. I know you didn't mean it. Okay, listen up. Art,
So since
Sure.
you did f of e, wouldn't it have to be 3e instead of 3g? Or like it doesn't not matter?
oh, you're right. The E should be a G.
Or
Yes, it does.
How did you get S?
Does it matter what
I
letters?
just, it's just, I wrote it as a function.
Does it matter what letters we use?
No.
We use M and G.
That's okay. Okay, here we go. Domain. So I was just explaining to you that we can't wrap half a gift and expect somebody to pay full price, right? So our reasonable domain is going to be written as whole numbers. Okay, you can't wrap half a present. That's just not right.
Yes, you can.
You can, but it's not ethical. And remember, this is a reasonable domain. So we know, yeah, sometimes you're not. So we know they can wrap, what's the least amount they can wrap?
1, 0.
0, 0. And then they can wrap 1, 2, 3. Now, are we gonna go all the way to infinity?
Yes.
No, they can wrap all the way to infinity, but we can't write numbers all the way to infinity. So then what we're gonna do, yes, dot, dot, dot. And then we're gonna write infinity. And what this means is it's from 0 all the way to infinity. without writing all those numbers.
Your infinity is there.
So then let's look at our range interval. Okay, it's gonna be the same thing. If it is strictly $3 a gift, then we start with 0. And then one gift would be 3, then 6, then 9, then ... to infinity. And this tells us that our increments are going up by 3s every time.
That'd be expensive. I wish I had infinity
Yes.
dollars on.
So
Me too.
it's really not, that part isn't reasonable, but since we don't know the reasonable, we can say it could be to infinity. Okay.
This wasn't.
Okay, let's go ahead and go down to these last problems. And I am going to show you how to plug in a function to an equation. You really know how to do this already. But notice that this is f of x. And then this one over here is g of x. Okay, so anytime you see a function with f, then you're going to use this equation. If you see a function with g, you're going to use this one. So yes, and then both is going to be, so f of 2 equals 3 times 2, because we're using this equation.
You just solve it.
Yes, you have to solve, folks. So f of 2 equals 6. Okay. Now let's look at the g. G of 3, we're going to use the g equation, 2x plus 1 is going to be, or it's going to be g of 3 equals 2 times 3 plus 1. Oh my gosh. The answer is 7. I put 7. Okay. So g of 3 equals 7. Okay, let's look at this one. We're going to take the function of 4 and add it to the g of 4. So we write it out like this. F of 4 equals 3 times 4. Okay, and we're going to solve that. And then we're going to add it to g of 5 equals 2 times 5 plus 1. So we solve each of these and then we add them together. So let's solve this one. We end up with f of 4 equals 12 plus yeah, equals 11. And all this means is that we are going to add 12 plus 11. And our answer is, yes, 23. Okay.
It.
Nope. Oh, you could write it out, but
F of 4 plus G of 5.
But like on the homework, we won't have to write that.
no, not like that. Okay, so let's do these next ones, guys, because these next ones can be a little bit confusing and our time is almost up. So we're going to take f of 3 minus 1. Okay, so the function of 3. This one's a little bit interesting. Okay, so the function of 3 is 3 times 3 minus 1. So function of 3 equals 9 minus 1, which is 8. Okay, now I'm going to, that's a multiplication sign. So then I'm going to take 8 and I'm going to multiply it by something. So let's do the g of 4. The g of 4 equals 2 times 4 plus 1. So g of 4 equals 8 plus 1. G of 4 equals 9. And then we're gonna multiply those together and we get 72. Okay? You guys, I do need to teach you this last one. If you want to go, you can, but I also have this recording so you can look at it on the recording. Does anyone want me to do it right now?
Yes.
Okay, here we go. You always work from the inside out. So the first thing that we're gonna do is we're gonna find G of 2. G of 2 equals 2 times 2 plus 1. So G of 2 equals 5. The next thing we're gonna do is we're gonna find the function of 5 because G of 2 equals 5. So the function of 5 equals 3 times 5. So the function of 5 equals 15. So your answer here is 15. Okay. All right, so that includes our lesson for 2-7.